Alright, you are welcome again. Today we want to talk about numerical analysis. Numerical analysis. Now let's go. Numerical analysis is a branch of mathematics that focuses on the development, analysis, and the implementations of algorithms for solving mathematical problems numerically. Okay, now in other words, it deals with methods to obtain approximate solutions to mathematical problems that are either too complex or impossible to solve exactly using analytic method. Now let me explain. I want to take my time to explain what numerical analysis is all about. Generally, equations can be classified into two major. Number one is we have algebraic equations. Then number two, we have what we call transcendental equations. Now, what do we mean by algebraic equations? We say that algebraic equation is a mathematical expression that relates one or more unknown quantities or variables to known variables or constants using algebraic operations such as addition, subtraction, multiplication, division, and exponentiation. Okay, now I'm very sure you understand what we mean by algebraic equations. Now, under this, we have polynomial equations. Under algebraic equations, we have polynomial equations. I'm very sure you know what we mean by polynomial equation. Example, you can have something like this. F of x is equal to 2x cubed minus 5x squared plus 3x plus 1. And then the next one, you can also have something like this. F of x is equal to x squared plus 3x minus 2 equal to 0. This is examples of polynomial equations. Now, these polynomial equations, depending on the power, okay, depending on the power or the degree. If the degree is 1, we have linear. If it is 2, we have quadratic. 3, we have cubic, and then 4, quartic, as the case may be. Look at examples. All right, good. Under algebraic equations, we just mentioned that we have, under these algebraic equations, we have what we call polynomial equations. And under it again, we have what we call rational equation. Rational equation is maybe you have two polynomials in form of fraction, numerator and denominator. Okay, example, when you have something like f of x is equal to g of x, okay, and the f of x and g of x is not equal to 0. So this is what we call rational equation. Okay, good. Under algebraic equation again, we also have what we called algebraic transcendental equation. We have what we called algebraic transcendental equations. We say that these are algebraic equations that involve both algebraic operations and transcendental function. It involves what? Algebraic equation and transcendental function. Examples of transcendental function include, we have exponential function, we have logarithmic function, we have trigonometric function, we have hyperbolic function, and the rest of them. The rest of them include Bessel function, gamma function, error function. All these we just mentioned are what we call transcendental functions. Now, when you have algebraic equation that involves transcendental functions, is what we call algebraic transcendental equations. Example, you may have something like x squared minus sine x is equal to 0. You have x squared coming from algebraic, and then sine x coming from trigonometric, which is transcendental. So this equation is called algebraic transcendental equation. Another one, you may have something like 2x cubed plus exponential x You get? So exponential x, this is exponential function. So this is what we call algebraic transcendental equations. Now we have just mentioned the two types of equation. Generally we say algebraic equation and then transcendental equation. Under algebraic equations we have three types. We have polynomial, we have rational, and then we have algebraic transcendental equations. Now this is all for algebraic equations. Now let's go to transcendental equations. Under transcendental equations we say that this is a mathematical expression that involve transcendental functions which cannot be expressed as finite combination of algebraic operations and power function. Example, we have exponential x minus 2 is equal to 0. This is pure transcendental equation. There is difference between transcendental equation and algebraic transcendental equation. Now, as the name implies, algebraic transcendental equation is an algebraic equation that involves transcendental. But when you talk about purely transcendental equations, this ones is explicitly for transcendental functions. You get? Example, you can have something like log x is equal to 2. You can have something like sin x plus cos x is equal to 1. So these are examples of transcendental equations. Now let's go. We just mentioned types of equations. So these equations have their own method for solving them. These are mathematical problems. So these mathematical problems have different approach and different method for solving them. So generally, all the methods can be classified into two majorly. Number one is what we call analytic method. Number two is numerical method. Okay, now what do we mean by analytic method? This method compute the exact value, the root in number of steps, and give all the root at the same time. This method, in other words, is called direct method. So this analytic method is another word, is a kind of method that will give you exact value. When you are talking about this problem, the solution is talking about maybe the root. Okay, so this analytic method will give you the exact value in just a number of steps. Okay, now another name for this analytic method is called direct method. Okay, so there are direct method for solving polynomial equations. Okay, polynomial equations, there are direct method for solving them, like linear equations, like quadratic equations, cubic equations, and then quartic equations. For instance, when you want to solve quadratic equation, there are many methods. So all these methods I'm going to mention are all called analytic or direct method. So for you to solve a quadratic equation, you can use completing the square. It is called a direct method. It will give you the exact value or the exact root. Okay, you can use quadratic method, the one generally called mighty formula. You can use a mighty formula to solve a quadratic equation. Another method, you can use factorization. You can use graphical method, and what have you. So all these methods I just mentioned are called direct or analytic method for solving polynomial equations like quadratic equations. All right, good. Now look at this. There is no direct method for solving polynomial of degree greater than 4 or transcendental equations. So when you have any polynomial equations that the degree is more than 4, there is no analytic method that can handle such problem. When you have an equation that involves transcendental function, there is no analytic method that can solve it. Or when you have a purely transcendental equations, there is no analytic method that can handle it. So this is the reason why it will bring us to the method called numerical method. So all the problems, okay, that cannot be solved using direct or analytic method, then we employ the use of numerical method. So what do we mean by numerical method? Now this method is based on successive approximations. You may not or cannot get the exact value, just like analytic give you exact, but a numerical will not give you exact, but will give you approximation very close to the root. Okay, very close to the what? To the root. Now under numerical or iterative method, there are different other methods under this numerical. Number one, we have what we call Newton-Raphson method. Is an example or a type of numerical or iterative method. We have what we call Chebyshev method. We have fixed point method. We have secant method. We have regular first position method. We have what we call bisection method or Bolzano method. We have Muller method. We have Bach-Vetters method. We have Bastos method, and what have you. So these are the examples of numerical or iterative method. Now in a consequent videos or lessons, you'll be taking all these methods one after the other to see how they are being used to solve problems. Okay, to see how we can use this method to solve numerical problems. Okay, now we are talking about numerical analysis. Okay, so and they will say that numerical analysis is talking about the development, analysis, and then implementation of algorithm for solving mathematical problems numerically. Okay, solving these problems numerically. So we are going to see how we can use numerical method to solve mathematical problems. Okay, now when you are using numerical method, and then we just mentioned that numerical method is talking about iterations. You perform different iterations, successive approximations. You do first iteration, second iteration, third iteration, fourth iteration, fifth iteration, and so forth. Now there will be a need for you to know when to stop your iterations. Okay, there will be a need, or there is a need for you to know when to stop. Now we call it the criteria to stop or to terminate iteration procedure. So number one, we have two major criteria. Number one is the equation f of x is equal to 0 is satisfied to a given accuracy. Now when you have an approximation that satisfies the equation f of x is equal to 0, you can stop. Yes. Now you do your first iteration and you obtain your result. When you place it inside the function and the f of x is equal to 0, you can stop. You have gotten exactly what you want because you are actually looking for the root. Okay, now another criteria to stop your iteration. We say the magnitude of the difference between two successive iterations is smaller than a given accuracy or an error bound epsilon. Okay, in such like this, when we say xn plus 1 minus xn is less than or equal to epsilon. Now what do we mean here? When your iteration starts to repeat itself, that is, the difference between them is very small, that is, it has started repeating itself, so that is when you can stop your iterations. So we have mentioned the two indications when you can stop your iterations. So in our next video, we are going to take this method one after the other to see how to use them, how to apply them, and then also how to derive their equations. So what we did today, we talked about numerical analysis, and then under numerical analysis we are able to generally spell what we mean by numerical analysis. There are some problems that cannot be solved using analytically or using direct method. So such problem we can employ numerical method, okay, to solve such problems. And then this numerical method include Newton-Raphson, Chebyshev, fixed point, secant, regular force position, bisection of Bolzano, Muller method, Bach-Vetters, Bastos method, and the rest. So these are the methods we can use to solve problems numerically. All right, yes. Now let's go.